So I'm going to talk about the treatment of inconclusive results in firearm error rate studies. This is joint work with Susan Vanderplas from UNL and Alicia Karikiri. So, okay, here we go. So what I'm going to do is I'm going to talk a little bit about error rates and then what kind of impact inconclusive decisions have on error rates. I'll introduce the concept of process error and then also look at how inconclusives affect this process error. So our overarching goal is always the same source problem. So do two pieces of firearms evidence come from the same source? That's the premise under which CSAFE has been founded. So this goes back to the NRC report from 2009 and then PCAST from 2014. Our goals are, we want to determine a score as an objective measure for the match, and for that there's some algorithmic ways of assessing similarity between pieces of evidence. And we also want to establish error rates. So what makes an error? That's really the question. So in order for us to be able to identify an error, we need to be able to say what some comparison should have been. So we need to be able to have ground truth. So that means that we need case studies, because case work in itself, we don't know ground truth. So we need somebody to administer some studies where that somebody knows ground truth, and then firearms examiners participate and will tell us what their assessment results in, so that we can then establish error rates. So in order to do case studies, there's a couple of things that we need to make sure of. The first thing is a participant, so the firearms examiner, does not know ground truth. So there's a separation. So that's there's a separation between administering a test and then taking the test. I think that's pretty obvious. That's what we have with other tests as well. The second premise is a participant should not be able to infer a conclusion based on anything else outside but the comparison at hand. So just based on a conclusion should happen on just a comparison of the material. The gold standard would be that a participant does not know that they are being tested. So that's where blind testing is inserted into casework. And if you want to know more about that, you can either follow this link. The Houston Forensic Science Institute has implemented some of this blind testing. Robin Mejia is also talking about this in room A. So in case you're more interested in that, you're in the wrong room, sorry, go to the other breakout room. So Robin is talking about how to implement blind testing. So that's really the gold standard. A participant doesn't even know that they're participating in anything. Oopsie. Reality is, most often we've got case studies, firearms examiners agree to do a number of case studies each year. And that means that they will know that they participate in a case study. And what usually happens is that a participant compares a number of questioned items to a number of reference items and comes up with conclusions, usually conclusions according to the AFD theory of identification. So AFD is the Association of Firearms and Tool Marks Examiners. And there's a set of rules for conclusions published. So this is published under different in different avenues, but this is from the AFD journal. So a conclusion, the range of conclusions essentially has 4 outcomes. The first one, for the first one, please look at the very bottom. The first one would be that each of the pieces is investigated, whether it's suitable for an examination. So whether there are any kind of markings that can be used to come to a conclusion using a comparison. So suitability is determined based on just an individual piece. All of the other conclusions would be based on a comparison between these pieces. And there's 3 pieces or 3 outcomes. We have identification on the other side. So that would mean that 2 items match both in class characteristics and in individual characteristics that that match. So to an extent of agreement that exceeds that which can occur in the comparison of tool marks made by different tools. So there's an agreement in individual characteristics. On the other side of the spectrum would be an elimination. There's either different class characteristics. So for example, different calibers, then obviously these 2 things can't have come from the same source. And or if the class characteristics match, the individual characteristics are different to a degree so that they can't come from the same source. In between those 2 extremes, we have the inconclusives. So inconclusives have a slide of almost identification to almost elimination. And you can see here in the middle, inconclusive B would be there is no agreement or disagreement in individual characteristics that would allow an assessment of whether this is an identification or an elimination. A tends towards identification, inconclusive C tends towards an elimination. So from the point of view from the examiner, a comparison that results in an inconclusive result is a perfectly valid result. And the examiner is doing the right thing in their job to say that this result is inconclusive. So in terms of errors, these inconclusive results are really a nightmare. As statisticians, as mathematicians, as data scientists, we love to have a black and white thing. So something is either right or it's wrong. And here we are somewhere in the middle. So what do? There's a paper by Dror and Skorich from 2020 called Misuse of Scientific Measurements in Forensic Science, published in the Forensic Science International. And here we've got an overview. This is called a confusion matrix. Don't you love those names? I hope it doesn't provide any more confusion. But what we're doing here is we're showing the ground truth in columns and the participants, so in that case, the firearms examiner's conclusion. And you can see how identification goes hand in hand with same source, exclusion goes hand in hand with different source. And we can all agree on that if something that's a different source is concluded to be an identification, a mistake has happened. If something from a same source was excluded, then another mistake has happened. So in the top 2/3 of this table, we have a black and white binary decision. So the question is, what do we do with these inconclusives? According to AFTI rules, those inconclusives are never considered as incorrect. So that means they're correct. So this is what AFTI thinks of this confusion table. And you can see that an inconclusive result from the examiner's point of view is a correct decision. Now that—
Hello to everybody that's still in this main room. If you are joining us on YouTube, maybe I could show you who I am. If you're joining us on YouTube, I apologize. We are experiencing technical difficulties translating the breakout rooms into YouTube live stream. So we are unable to do that at this time. We're working on a fix, and I hope to have one before the end of the day. At the very least, session 3 will be resolved. And because of this issue, I will just make sure that getting these recordings up is top priority. So these recordings for all of the sessions will be available on our website shortly following the event. I guarantee it will not be today, but hopefully by tomorrow, those recordings will be up by the end of the day, and you'll have access to all of the breakout sessions. Again, I apologize for the struggle there. If you are joining us on YouTube, I think for right now, what I'll do is I will add one of the breakout rooms into this main room for the next 2 sessions, and we'll try to resolve it at least a little bit that way. You may not necessarily get to choose the breakout you desire, but you will have access to one breakout room beginning at 11:45. Thanks for your understanding. For those of you in the Zoom meeting, if you would like to be assigned and you just joined us, please let me know where you'd like to go, and I can put you in a room, or you could wait for the 11:45 session.
Thanks, Anthony. That was just the message of our principal. Okay, so inconclusives. So inconclusives are this weird thing between identification and exclusion. And obviously the way that we treat those inconclusives hugely impacts error rates. According to the AFTI rules, inconclusives are considered correct, but we also need to think about the overall process. So if the overall process doesn't result in an identification or an elimination, something went wrong. And that could be the relatively small error that the examiner has made an error. But to that, we also need to add the relatively large probability that the firearm didn't mark very well. And we can't discern the marks. There are some marks, so the thing that we're looking at is suitable for a comparison, but the marks are not made consistently. So that is what we call the process error. And this goes hand in hand with the Drawer-Scourge proposal from 2020. What Drawer and Scourge are doing is they expand on the evidence side from same source and different source to also have an inconclusive category. So now we've got a 3x3 matrix, and we know exactly what we need to do. We put all of the correct decisions on the diagonal, and everything that's off the diagonal is an error. And then we remove the inconclusive category because we don't know how to prepare evidence that is inconclusive. So this is what we're left with in terms of the confusion matrix. And you can see that for the process, any kind of inconclusive is considered an error because it did not result in either an identification or an exclusion. So this is, again, the other side of the scale. Everything is an error. So all inconclusive results are considered an error. So before we go any further, we need to actually check whether inconclusives actually happen, because if they don't happen in practice, then we're talking about a non-issue, and everything resolves itself, and we're just in the upper 2/3 of our confusion matrix. I can see that there's a couple of messages popping up in the chat. Susan Vanderplas, my co-author on this paper, is going to field those kind of messages. So let the questions come. I'm not going to answer them. During the talk, I will answer them at the end of the talk, after the talk's done, unless Susan is already answering them now. Okay, so we went into the literature and we pulled out case studies regarding any kind of firearms evidence. So here is an overview of all the different pieces of firearms evidence that are available since about 2009. Most of the studies deal with cartridge cases and breech faces. So you can see here the famous Baldwin study. So that's the Army Lab study that came out of the Midwest Forensic Research Center. Then we've got Keisler, Bunch and Murphy, Fadul, Dues, Chapnick et al. That's also called the VCMER study, Virtual Comparison Microscopy Error Rate Study. And then the FIGHT study from 2009 that was then published in 2013. So all of those are regarding cartridge case identifications. Then there's several bullet land comparisons. Hamby, here, this is Hamby 2019, but the study goes much, much further back. It's more like 15 years of study summarized in this paper from 2019. And then also FIDE 09 has a separate set of not just cartridge cases that are in the upper item, but also bullet comparisons. Leon et al. Have looked at extractor marks, and then Mattison also looked at firing pin aperture marks. So we looked at all of these studies. Some of them are in italic. Those would be studies that used virtual microscopy. And we had a look at how many inconclusives we found in each one of these studies. So here's an overview of that. The percentage of inconclusives is shown as a dot. The limits here show 95% confidence intervals. And you can see that in the middle, so there's about a 25 to 30% rate of inconclusives across all of the studies. Some studies have a slightly better rate of inconclusive results. Some studies go much beyond those 25% and are closer to 50%. Some 55, almost 60% of inconclusive. So almost more than half, almost 2/3 of the comparisons from Bunch and FIDE, the bullets, resulted in inconclusive results. So that means that inconclusive results are, these kind of conclusions happen, they're quite prominent, and we need to figure out what to do with them when we're talking about error rates. So one way to go is to not count inconclusive decisions as final and only allow identifications and no identifications. So rather than talking about exclusions and identifications and inconclusives, what we can do is we can say an exclusion is not an identification. And that seems like, yes, okay, it's not an identification. But we can also say that an inconclusive is not an identification. And that allows us that we can apply the same error typing to the inconclusives as for the elimination. So essentially, we're treating an inconclusive as not an identification. So that means that if they're a different source to start with, we would consider a inconclusive as correct or not an identification. And if they were same source to start out with and resulted in an inconclusive, then we say that this is an error. So we count inconclusive results as exclusions or eliminations. So now we've got these three different types of errors. So AFD looks at just examiners, at errors that examiners make. We've got the overall process error where things don't go the way that they're supposed to. And then this more practical decision to say, well, it's either an identification or it's not an identification. So let's compare these three error rates across the case studies that we've got. And you can see here again, the dots show where the error percentages are. Those ranges show confidence intervals. If the ranges are pretty wide, that means there's a lot of variability, usually because there's only few comparisons being made. So the very small confidence intervals are usually in places where we've got quite a bit of data, or where we're very, very close to zeros or ones. Luckily, there's no 100s here. So what do we see? First of all, AFD here in green, AFD errors, by definition, AFD counts only examiners errors. So AFD errors are always the smallest out of the three. And process errors are the highest, because anything that's not resulting in a same source or in an identification or a elimination is counted as an error. So here we can see that elimination, counting inconclusives as eliminations, is going along with the process error. So here we're looking at the percentages of same source comparisons that were not identified as such. And you can see that for the US and Canada, for those firearms examiners, this is not a huge, so the percentages, the error percentages are all relatively small, except for the virtual comparison, where there were more inconclusives. So how does that look like for different source comparison? And here you can see that the process error are really big. That's because there's so many inconclusives. And it also turns out that most of these inconclusives were actually made on comparisons that were from different sources. So a lot of different source comparisons didn't result in eliminations or exclusions, but were called inconclusives, which is why these error rates here from the process error are so high. If we count all inconclusives and elimination, you can see how the eliminations, how those error rates go back down to match with the AFD errors, and things are siding with AFD again. So I'm running out of time. If we count inconclusive results as, oh great, thank you. Okay, I think that was it. We were chopping off the last 5 minutes. Please put questions into the chat. And thank you for listening. I'll make sure that you also get the last slide. I'm only missing one slide here. Thanks, everybody.